This is about intercepts. We're at top of page 9. So an x-intercept is literally where you're touching the x-axis. X-intercepts is where you intersect, where you cross the x-axis. So what is the y value what's the y value of the x-axis? What is the y value of your x-axis? 0. So your y-intercepts occur at, your x-intercepts occur at y equals 0. Okay, so here are your x-intercepts. Now let's talk about y-intercepts. Your y-intercepts occur when it intersects, where it crosses the y-axis. What is the x value of the y-axis? 0. Oh my gosh, so the y-intercept is where x equals 0, and the x-intercept is where y equals 0. This is not new. This is the Algebra 1 and Algebra 2 review. Cool. So, no surprise. To find the y-intercept, find f of 0. Literally, plug in 0, and you will find where you cross the y-axis. If you want to find the x-intercepts of a graph, they're called the zeros. They're the roots of this equation. They're the solutions. X-intercept, 0, solution, root, those all mean the same thing. Those 4 words are synonymous. The zeros of the function are the roots of the equation. They're the x-intercepts. It's where y equals 0. So, to find it, you set the function equal to 0 and solve for the independent variable, aka fully factor it, set all the factors equal to 0. Wait, we did this before. Remember in chapter 5 we solved equations? This chapter 1. Remember, it's where you're supposed to start. So hopefully this is a little bit easier. Alright, because this is functions, right? Algebra 1, Algebra 2 from a calculus perspective. So we're trying to use interval notation and talk more at a higher level about these graphs. So really have some basic intuition of what graphs look like, how they'll move, what is happening at the endpoints. It's really putting everything together that you've already learned in your past 2 algebra courses. Okay, use the graph of each equation to approximate its y-intercept and 0. So remember, zeros are the x-intercepts. Then find these values algebraically. Okay, so first, let's find the y-intercept. Alright, so I did it in green. What is the y-intercept? 0. Okay, and an intercept is a coordinate. It's literally the place where it's crossing. So you have to have an xy coordinate. So it's going to be 0, 0. So if I plug in f of 0, I get 0 cubed minus 0. So this is checking it algebraically. Look, it's 0. Great job, guys. Is this helping your confidence, hopefully? A little bit. Yeah. I found that this first mid-chapter test goes very well. It should be a good boost, but with that being said, you still gotta pay attention and show the effort. Okay, the zeros are the x-intercepts. Let's see where we touch the x-axis. Where are my zeros? Alright, so we see we touch at x equals 0, at 1, and negative 1. So if I would write this in coordinate form, so I'm just trying to be very clear, coordinate form, that way you understand the y's are 0 for all your x-intercepts. Last year I was not specific about this. I was whatever, as long as you write what x is, but trying to help you guys remember. Y is 0 for your x-intercepts. Okay, so now I've got to algebraically check this value. So remember, to find the x-intercepts, you plug in y for plug in 0 for y. Okay, so before I go over this, we're going to play a game called What is Wrong? What am I doing wrong? Spot the error. Okay, that's the game called. We'll just call it Spot the Error. STE. No. Okay, spot the error. Okay, what is wrong with what I'm doing? Okay, blah, blah, blah. Add x to both sides. Blah, blah, blah. Blah, 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 blah. Blah, 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 blah. Plus minus 1 equals x. I found it. There's 2 things. No, this is wrong. This is wrong. Okay. So, why not? I can add x. Right? Let's see. what's it called? Equality, addition equality of algebra. No, something. I don't know. I forget. It's been 2 months. Whatever. As long as you do it on one side, do it to the other. It's the additive property of equality. That is it. Additive property of equality. If you add to one side, you add to the other, it's fine. Whatever. But where is the issue occurring? I can add it to both sides. The issue is when I'm dividing by x. Because what if that x was equal to 0? You can't divide by 0, so that's an issue. If my x was 0, which, hey, wait, what? One of my x's is 0? One of my solutions is 0? I would be dividing by 0. Cannot do that. I come up with ways to write that on people's tests of like, that's not how math works. You cannot do that. This is wrong. But I want to be more specific. So I'm showing you, because it wasn't just one person. I would talk to them. This was sprinkled throughout both sections of like, ugh. But the way it looked on your test was negative sine theta equals negative sine squared theta, or negative cosine theta equals negative cosine squared theta. Depending on which version you had, I just switched cosine and sines. No surprise. So divide by sine on both sides. But the issue is, what if sine was equal to 0? You can't just divide by sine. So this is why I'm bringing it up. It's a great time to review some of the stuff that we did wrong on our test. So the issue was dividing by x. I lost a solution. And you don't want to divide by x because, oh, there's literally an x value that I can't include, which is the one that makes my fraction go to 0, which is 0. The way you have to do it is you have to fully factor and set each factor equal to 0. Is there a common factor in x cubed and x? So I pull out an x and I get x squared minus 1. So let me just cross that so it's clear. It is capital W, capital R, wrong. Okay, x squared minus 1 is a blank, blank, blank. Blank of blank. Difference of squares. Difference of squares. Okay. Difference of squares. So wait, what does this mean for me factoring? Like, exactly. X plus 1, x minus 1. And if you're out there thinking, what the hell is the difference of squares? Like, oh my god, what? That is the perfect topic for Alex. Alex. Do it on Alex. Also, I covered it earlier this year. Okay. And then, since I have all my factors, I set each equal to 0. Aha! So notice, I came up with my plus and minus 1, but I was missing my 0. Ooh. So you lose solutions when you try to divide like that. So if it was like, okay. So if it was like 0 equals 2x squared minus 2, and then you like have 2 on both sides, you're not dividing by 0 if you divide by 2, right? So that's the difference between dividing by a variable or dividing by a number. And when I had sine of theta, the theta is a variable, so you can't just divide by sine of theta because there's some unknown in there. There's going to be a solution that maybe could be a 0, so you don't want to do that. Okay, so algebraically approved. Those are my zeros. We're good to go. Other questions? No. What a fun game. I wish that I could actually have a game show where I could like give you prizes for spotting what's wrong with my math. Oh, I could give you prizes. I could give you participation points. So dumb. Okay. Let's do this next one. So, same things. Find the y-intercept, find the x-intercepts, find them algebraically. So first we'll look at the graph, do it, and then we'll prove it by algebra. So first, let's find the y-intercepts. Where am I crossing the y-axis? 0, -3. Cool. And if I want to prove it algebraically, I just plug in 0 for x. So you have 0 minus 0 minus 3 is -3. Okay, cool. Check, check. Look at you. Solid. Solid. Okay, now my zeros. So this is my x-intercept. I'm just going to be a little extra. X-intercepts is when you plug in 0 for y. So I have 0 equals 2x squared minus 5x minus 3. And then we have to factor. So the old case-if method. I don't know. Is that what you call it? Case-if method? That's what I call it. All right. How do you deal with a coefficient in front of x squared that's other than 1? So I go multiply. So I have x squared minus 5x minus 6. And if I factor this out, what multiplies to negative 6 adds to negative 5? Negative 6 and 1. Great job. So I would fill in 2x minus 6, 2x plus 1. And then this is like the trick. Notice there's a factor of 2 I can divide out in this. So it turns into x minus 3 times x squared plus 1. That's one way of doing it. Or, if you're like, I don't like that, you could say, okay, the only number that multiplies to 2x squared is 2x and x. And then the only number that multiplies to negative 3 is 1 and 3. So then you have to do some, guess and check. But lucky for us, we already figured it out over here. All right, then I set each factor equal to 0. X minus 3 equals 0, so x equals 3. 2x plus 1 equals 0, so x equals negative 1/2. Oh my gosh, we forgot to look at the graph first. Oh, I forgot to look at the graph.
Yeah, because I was going to say
Why didn't you tell me?
From the graph.
Okay.
But I thought you wanted
No,
to show us how
I forgot, my bad. Yeah, so I found the zeros at 3, 0.
It's on a graph, do we need to show, how you get the x-intercept?
So the idea was you see where it crosses the graph, then I'm proving it to you algebraically. So that way we don't have to have the graph in the future.
Well, you got to prove it first.
Yeah, didn't mean to do that.
It's fine.
Not to have you see it on the graph, because x-intercepts where you cross the axis and you're like, there's where it crosses, then you do the algebra. It's not even noon. What is wrong with me? Alright, do we have questions over this? Nah, maybe. The hardest part I think is just the coefficient other than 1 in front of x squared. That's the hardest part. You've done this before. And now, tests for symmetry. What does it mean if I say symmetry or something symmetric?
It's the same.
It's the same on both sides. So there's all these studies where it's the most beautiful people have symmetric faces. Whatever. It's just because their left side looks like their right side. Whatever. A butterfly, literally a butterfly has symmetry. What'd you say? Sorry?
No, I don't like butterflies.
Oh, that's why you're turning away from me? I'm not a butterfly. Definitely still in my caterpillar stage. Okay. Definitely still there. Okay. So, symmetry. When we're talking about graphs, you either can be symmetric across the x-axis, right? It's symmetric across the x-axis. You can be symmetric across the y-axis. Or you could have this symmetry where it's you flip it upside down, 180 degrees, and it's the same thing. Okay, those are the three. So the first one is symmetric with respect to the x-axis. So notice that if you replace y with negative y, you have an equivalent equation. So literally, if you have the same x, the equation will have x comma y and an x comma negative y. So you'll have 2 points that are the same distance from the x-axis. So it's symmetric with respect to x-axis if you have 2 points that are the same distance from the same x. It's symmetric with respect to that was with the x-axis. Symmetric with respect to the y if your graph, you have 2 points that have the same height, the same y, and they're the same distance away from the y-axis. So they just have literally a 5, 4 and a negative 5, 4. Same y value, opposite signs of the x. It's symmetric with the y. You look at it and you're like, oh, it's the same distance on both. And it's symmetric with respect to the origin. If literally you have a point on your function that you have x comma y, and then you have a point that's just the opposite signs, negative x, negative y. So how do you actually find them algebraically? Respect with the x-axis, plug in y plug in negative y for y, simplify, and you should get the same equation. How do you get symmetric with the y-axis? If you plug in negative x for x, you'll get the same equation. And then lastly, how do you get respect to the origin? You plug negative x in for x, negative y in for y. Do the whole algebra simplification, and you'll get the same thing. Okay, so here, okay. It is symmetric with respect to the x-axis. You plug in negative y and simplify. All right, so first let's see. Is this symmetric with respect to the x-axis, y-axis, or origin? Part A. Yeah. Is it symmetric to, there's three options. Is it symmetric to the y-axis? No, because that would look something like, oh my god, come on. It would look something like that if it was symmetric with the y. Is it symmetric with the origin? No, because then it would look something like this. Is it symmetric with the x?
Yes.
It's like you flipped it over the x. Okay, symmetric with the x. If it's symmetric with the x-axis, substitute negative y in for y. So I'm testing if it's symmetric with respect to x, so I plug in negative y for y. Simplify, I get the same thing that I started with. That's how I know it's symmetric with the x-axis. This WRT means with respect to the x-axis. So it's symmetric to which one? The x-axis. All right, let's see if that's true. So I have negative 4 comma 2, and then I have a negative 4 comma negative 2. The thing that's different is the y. The y is just the opposite sign, right? The y, and you plug y in for negative y. I'm sorry, you plug negative y in for y. You see, you have x comma y, and then you have x comma negative y. It's just flipping the sign of the y. Okay, I have drilled this into your brain. Let's look at this next one. So, is this symmetric with respect to the origin? Nah. Respect with the x-axis? No, it's literally being flipped over the y. Alright, and I can prove that to you. So I see a point here and a point here. I have 4 comma 0 and I have negative 4 comma 0. Alright, so huh? Yep. Yeah, sorry. Yeah, good one. I just saw the, oh my god. Okay. Perfect. So it's symmetric with respect to the y-axis, and let's double check we are correct. So if it's symmetric with respect to the y-axis, we can substitute in, did I not give you a function? All right. It's not at all. Like, it's not. This is y equals okay, I got this. Negative absolute value of x plus 3. There's our function. That is the function. Whoop whoop. Okay, ready? Let's plug in negative y and see what we get. Oh wait, no, I'm sorry. Plug in negative x. I'm so dumb. X-axis, you plug in negative x in for x. So I'm plugging in negative x for x. Oh my gosh, what's the absolute value sign do? Positive. Makes it positive, and then I multiply by negative 1. I get the same thing. It's the same graph. Wonderful. Okay. Let's try the next one. Does that make sense what I'm doing? So if it's symmetric with respect to the x, plug in negative y. Symmetric with the y-axis, plug in negative x. If it's symmetric with the origin, plug in negative x and negative y, and you should get the same thing. Cool. Let's try this one. This is got this. Negative 1/2 x cubed. This is negative 1/2 x cubed. I'll teach you how to find the equations in the future. Yeah. Yes. Okay. So, is this symmetric with the x-axis? No, because it's not just mirror image across. Is it symmetric with respect to the y? No, because it's not just mirrored image across. It's the origin. And to test this, look, I have 2 points. So this is -2, 4. And if it's symmetric with the origin, I'll have the same numbers but opposite signs. So 2, -4. Okay, and so if it is symmetric with respect to the origin, I can plug in -x and -y, and I should get the same equation. Let's check. So -y equals -1/2 -x cubed. A negative times a negative times a negative. Okay, 2 negatives together is positive, but times a third time stays negative. So I have -y equals -1/2 times negative of x cubed. So notice I don't have parentheses around x anymore because I already cubed my -x. And it turns out a negative times a negative times a negative is negative. Try saying negative 50 times. So I have y. Let's see. I'm just going to simplify the right side. A negative times a negative is a positive. So I have 1/2 x cubed. Oh my gosh. I don't want it negative y. I want it positive y. So I'll multiply both sides by -1. I get -1/2 x cubed. Hold the phone. This is the same thing we started with. Yo. Check it out. Okay, yes.
Do we always have to prove the algebra?
If it says to, you have to. Like I didn't even answer your question. Sassafras. Of course. If it says to prove it, then prove it. Does it say prove it? Yep.
Where?
What?
It says to test.
Use the graph of the equation to test. Yeah, we're testing it.
Like, can't you just use the graph?
Wait, how come you didn't make the 1/2 positive? Because aren't you multiplying the entire thing by -1?
Okay, so right here, I have a negative times a negative, so I multiply these, and they, oh, hold on, take 2 seconds. Okay, it turns positive, right? That's why this is positive.
No, I mean in the,
And then-
one step above that.
Wait, what?
Because the original equation was -1/2 x cubed.
Yeah, so I have -1/2 x, -1/2, and then this is my x cubed. I'm plugging in -x for x.
Oh, you're just plugging in -x and -y.
Yeah, so I plugged in -x and -y because this is proving that it's symmetric with the origin. Because I do get the same thing at the end. Okay, fine. Let's do what the actual directions say. So, use a graph to test for symmetry. Let me pick a point. Check this one. Ugh. And this one. So I have -2. Oh my god, come on. -2, 1. And then I also have 2, 1. Wait, the only thing that's changing, what?
This isn't a function.
Yeah, I know. It said it said graph of the equation. Graph of the equation. It didn't say function, just said equation.
Wait, I just learned the circle formula yesterday at ACT tutoring.
X squared plus y squared equals radius.
No, wait, no, it's x. It's the
Parentheses
No,
x minus h
no,
squared
yeah,
plus
yeah, the h and the
y
k.
minus k squared. Yeah, equals 1. Equals the radius.
Radius squared.
Yeah. Great. Good. Look at you go. What?
I just haven't already took that same
Bomb. It's great. Yeah. Okay, so D, check it. So my y values are the same, but x is changing. So wait, if y stays the same and it's just x changing, the x is changing, that means it's symmetric with the y-axis. y-axis symmetry. Let's test for x-axis symmetry. So I have 0, 3, and I have 0, -1. Oh, keeping x the same, y is not just changing its sign. It doesn't have any other symmetry. It's just y-axis. So, even and odd functions. Functions that are symmetric with respect to the y-axis are even. Functions that are symmetric with respect to the origin are odd. And if they are not symmetric with the x or with the y-axis or the origin, they're called neither. So you either have even, odd, or neither. Those are your three options. I don't know why it's funny. I'm telling you, when I ask for the symmetry, you have three options. Don't write anything else because those are your three options. There's no answer D. Okay, there's no D choice. Those are A, B, C. Okay, let's talk about the even odd identity from chapter 5. What is wrong, Ariella? What is wrong?
I was just laughing at the different voice. You said never.
Never.
So I just thought it was funny.
What a day. What a day to be alive. Okay. So, do you remember how the even odd identity said cosine of negative theta is just equal to cosine of theta? This is literally the even odd identity from the last chapter. You don't have to memorize, just have you seen it before?
Yes.
Yeah. Okay. Ready? Let's graph. What does cosine look like? Start at max, go to 0, down to a min, back to a max. But wait, what if I made the graph on the left side as well, right? It goes down.
So it would still be the same thing.
Look at the left half of the axis versus the right half of the y. Symmetric with respect to the y-axis. With the y-axis. And if it's respect to the y-axis, it's called even. Cosine's an even function. Check it out. That means... this is what I tried to explain last chapter, and it is what it is. So that means for every x in the domain, so I'm reading the right half of the table, I'm just having you look at cosine graph. For every x in the domain, negative f of x equals f of x. So negative f of x, I'm sorry, oh my god, I wrote it wrong. F of negative x is just equal to f of x. Oh, that's cool. Cosine negative theta is just cosine theta. Boom. No. Okay. That's fine. Cosine is even. What if I want to graph sine? Interesting. I don't know. Let's check it out.
Because I remember from the paper, it was the origin of the same.
So wait, that's weird. So if I have a point here, oh my gosh, that's not a crazy enough different color. This point and this point, this was literally pi over 2, 1. And this was negative pi over 2, negative 1. Ooh, so both x and y are different signs.
They're odd.
It's odd. Literally, if I take the graph and rotate it 180 degrees, it's going to be the same graph. So that's what you could think of it. You switch the signs of both x and y, or you look at the graph and you turn your paper upside down. It's going to be the same graph. There's a shortcut for you. Okay, so, yeah. So back to even odd identity. So that's why if I would have sine of negative theta, it's the same as negative just sine of theta. Because if you have f of negative x, it's the same as negative f of x. It's the same function. It just flips it over the x and y axis. Okay, doke. Example 5. Graph each function on your calculator. Analyze the graph to determine whether the function's odd, even, or neither. Confirm algebraically. Do you not have a calculator?
Oh, still charging.
Oh, you charged it here overnight? Beautiful. You can grab it.
Can you grab me one?
Oh my gosh. I can't.
Oh, I need to charge it. Mine's at 29%.
I'll get a charge.
Bless. This is our last page. So, graph each one on our calculator. So, x squared minus 4x plus 4. Okay, so I'm going to go I'm going to go at a lively pace. Oh my god, I did not select this? Oh my gosh, guys. Okay. Oh my god. I can't do this. Menu, graph entry, edit, function. Let's delete this. Let's go menu, actions, clear all. Delete all. Goodbye, piecewise. Yes. Okay. Oh my gosh. How do I enter my graph? My command line's gone. Push. Tab.
Oh.
Look, I pushed tab. Oh my gosh. Guess what? It disappears.
Oh.
I can't enter. Push tab. Oh, there it pops up for me to enter. Just basic calculator skills. Just trying to have you guys know what you're doing. All right, let's go and let's enter in x squared plus, no, minus 4x plus 4. Look at it. Ooh. Do we have symmetry?
Yes.
What? With what? Origin? No. Y-axis?
Yeah.
No. X?
I don't know.
No. Neither. There's only 3 options. Either it's going to be even, odd, or neither. Either. So it is going to be symmetric across the y-axis.
Oh, symmetric.
Or it's going to be symmetric with the origin, which is odd. This is neither. This is neither. Let's go prove it. So it's neither. Confirm algebraically. So let me check for even. And if you want to check for something being even, you have to plug in. Okay, so to test whether even or odd, you plug in negative x in for x and see what happens. Neither. So plug in negative x for x and see what happens. So I plug in negative x. So negative x squared minus 4 times negative x plus 4. So this turns into x squared plus 4x plus 4. So is this the same equation we started with? No. It's not the same equation we started with. If it was the same, right, that means it would be even. So I'm testing to see if it's even. So if I get the same thing by plugging in negative x, same function, it would be even. This is not even, right? It's not even because this is not what I started with. Okay, let's see if it's odd. Okay, so if it was even, I would have gotten the same equation. If it's odd, everything would have been the opposite sign. Is everything the opposite sign? No, so it's not odd. So I just proved it's not even or odd. Let's do the next one. X squared minus 4. So I have to push tab to get back. I can scroll up, delete, and I just want x squared minus 4.
Wait, how do you determine if it's off? Sorry.
So when you plug in negative x, okay, for x. If you get the same equation you started with, it's even. If everything's the same except it's opposite sign, what used to be a plus is now negative, what used to be negative is now plus, it's odd. Yeah. All right, so okay. This is going to be even. It's symmetric with the y-axis. Symmetric with the y-axis, even. So I know it's going to be even. And let's prove it. So plug in negative x in for x. If you get the same equation, even. If every sign is exactly opposite, it's odd. And if neither one of those is true, guess what? It is neither symmetry. So f of x equals, okay, I'm plugging in negative x. Negative x squared is just x squared minus 4. I get the same thing I started with. That's how I know it's even. It's the exact same thing I started with. All right, let's try the next one. Have to push tab to get back. delete everything I had before. So for the next one, what? Okay, so I'm gonna be fancy. I'm gonna use my template key. I'm gonna make a fraction. That way you don't have to. You can use parentheses and the divide by symbol, but I just want to be extra today. So I have x squared over x to the 4th plus 1. So x to the 4th plus 1. Oops. Plus 1. Ooh, interesting. It looks like it is... What do you notice? Symmetry across the y, which means it would be even. Yeah, so the way I think about it, if it's symmetric across the y, what you have on the left is what you have on the right. Yeah, look, it's even. Haha, no, you don't look at my hands. That's fine. No one's looking at me. Okay. If it's symmetric across the y, what you have on both sides, it's even. Ah, it's like you're a scale. It's even. If it's exactly opposite, you're like, what the heck? It's harder to tell. I don't know.
Does it look like the same on both sides?
Yep. If it looks like it's going to be exactly the same, probably just going to be even. So we're pretty sure this one's going to be even. So I'm gonna plug in negative x for x, see what happens. So I have f of negative x is equal to negative x squared over negative x to the 4th plus 1. It's the same. So what this says is f of negative x is the same as f of x. That is the definition of even. If I got f of negative x is equal to just negative f of x, literally everything is the same, it would be odd, but here it's just even. Okay. Go ahead, plot this. Yeah, it's exactly odd.
Okay.
So one way to look, so when I look at even, it's like, oh, it's the same here. The way I think about odd is literally if you rotate it 180 degrees, it's the same thing. So if you look, it's going to look the same, right? Turn your head upside down or turn your calculator upside down. Turn your calculator upside down. Same graph. So imagine if you took what's in the first quadrant and you reflected across the y and reflected across the x. It's like a double reflection. Yeah. So imagine we took what's in the first one, reflected across the y, and then reflected across the x. That's more or less what origin symmetry is. Yeah, the odd. Okay, it looks like it's odd. We're pretty sure it's odd. So odd means when I plug in negative x for x, I should just get negative f of x. Should be the same equation, except everything that was positive is now negative, everything that was negative is now positive. So f of negative x is just going to be 1 over negative x. Oh, so this is literally just going to be negative of 1 over x, which is just negative what my original function was. So it's odd. How are we feeling about this so far? All right, and then last one. Do you guys know how to do the root symbol? The control and then the square. It's a little blue above the square. So this is just going to be x squared minus 3. Ooh. Looks like it's the same on both sides, so it's going to be even. Symmetry across the y-axis, even. So I didn't give you a lot of ones that were neither, but clearly if it's different than what you started with and it's not just the opposite signs, then it's going to be neither. Okay, so this tells me that f of negative x should just be the same as what I start with. So let's plug it in. F of negative x equals negative x squared minus 3. So that's just going to be square root of x squared minus 3. That's the same as what we started with. Perfect. So let me pull up the practice quiz just so we can talk about it for 5-6. Just kidding, we have 5 minutes. Okay. So, I mean, this is good practice. I'm not going to give you a set builder on your quiz. Just good practice. Finding the value, this would be good for you to do. Analyzing graphs, so intercepts, even, odd. So you do get to use your calculator.
Yay.
Yeah. But this means you have to, 3 words, blank your blank. Show your work. Do you like this fill in the blank game we play? Show your work. So this is for many reasons. It's so I can give you as many points as possible. The easier it is for you to communicate with me, the better. You're not going to be sitting there when I grade your quiz. So I want it to be clear, right? So show your work. State the domain. Yeah, literally it's just going to be a page front and back. Shouldn't be too bad. So even, odd, or neither. So all you have to do is plug in negative x. If you get the same thing you started with, it's even. If everything is the exact opposite sign, what was positive is now negative, what's negative now positive, it's odd. If it's neither. If it's not with those 2 choices, that's it. Domain, so symmetry, describe the symmetry. So is it x-axis, y-axis, both? So for these ones, you can literally draw a little graph, and you could, I don't know, try to help you show work. Domain, did we have any big questions? So your quiz is Wednesday. After the quiz, we'll start 1.3. I'm confident in your guys' ability. I'll let you out a couple minutes early.